In today's lecture, we are going to start with the chapter Linear Inequalities. Or say linear inequations. So what are these inequalities? This sign is a sign of inequality which represents less than. This represents more than. This represents less than or equal to. This represents more than or equal to. As in both of this, say x is less than 5. So if x is less than 5, then 5 is not included. So it is strictly less. So these two inequalities are also called strict inequalities. And this too, as say x is less than or equal to 5, 5 may also be included. So these are loose inequalities. Next, there are two rules that we need to remember in order to solve questions from this chapter. The first rule says that equal numbers may be added to or subtracted from both sides of an inequality without affecting the sign of inequality. Second rule, both sides of an inequality can be multiplied or divided by the same positive number. So we can divide or multiply both sides of an inequality by the same positive number, and that will not affect the sign of inequality. But when both sides are multiplied or divided by a negative number, then the sign of inequality is reversed. So say 1 is less than 2. If I multiply minus 1 on both the sides, so minus 1 and minus 2 we get. So 1 is less than 2, then minus 1 is greater than minus 2. On multiplying by negative sign, or minus 1, what is happening is the inequality is getting reversed. We'll discuss them in detail in the quotients itself. And another concept that you need to remember is the replacement set and solution set. We are going to deal with this or understand this also in quotient itself. So the first question, solve 30x is less than 200 when number 1, x is a natural number, number 2, x belongs to the set of integers. Z denotes integer. So in the solution, first we are taking 30x less than 200. So we need to keep x on one side and find what x is greater than or less than a certain number. So what we are doing is we can multiply or divide by the same positive number on both the sides. So this implies 30x by 30 is less than 200 by 30. Since it is a positive number that we are dividing with, the signs will not change, it will remain as it is. So this implies 30 cancel off, x is less than 0 cancel off, 3 6 18 plus 2, so 6 2 by 3. So first part, so when it is given in the question that x is a natural number, so the replacement set, this that we need to replace with, what set is given is called the replacement set. The replacement set here is n. N denotes the set of rational number. Therefore, the solution set is the set which contains the answer. So the solution set will be x is less than 6 2 by 3. So we'll have all the natural numbers below 6.67, around 6.67. So that will have 1, 2, 3, 4, 5 and will include 6 as well, because this number is bigger than 6. So we can include 6 as well. So this is our solution set. For the second part, it is given that x is an integer. So the replacement set here is the set of integers. Therefore, the solution set is will have x as less than 6 2 by 3 and x is integer. So the biggest integer here will be 6, 5, 4, 3, 2, 1, 0, minus 1 and this keeps on going. So we'll represent this with 3 dots, that this will keep on going, this will not stop. Second question, solve 5x minus 3 less than 3x plus 1 when number 1, x belongs to the set of integers, part 2, x belongs to the set of real numbers. Also represent the solution on the number line. Okay. So 5x minus 3 less than 3x plus 1. First we will solve it. 5x minus 3 less than 3x plus 1. So first of all, what we are doing is we will try to remove this 3. So we'll add 3 to both the sides. So we get 5x is less than 3x plus 4. Now what we'll do is we'll subtract 3x from both the sides. So on adding or subtracting, the signs do not change, it remains as it is. So 3x cancels off, we get 5x minus 3x is 2x less than 4. 3x minus 3x cancel off. Now 2x by 2, we are dividing by 2 on both the sides. So what we get is x is less than 4 by 2 is 2. So x is less than 2. So first part given to us is here. The replacement set is the set of integers. Therefore, the solution set is in the previous question we had x less than 6 2 by 3. Since this was around 6.67, this is approximately equal to 6.67. So below 6.67 we had 6 as well because it was less than sign. But over here when we have less than sign, x less than 2 and x is an integer, so 2 will not be included. So we'll have a 1, 0, minus 1, minus 2, and this will keep on going in the negative integers. And to represent them on a number line, what we'll do is we'll make a number line first. Let's say we take 1 centimeter gaps. So we have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So the solution set is 1, 0, minus 1, minus 2. Okay. And when it is integer, we are taking only that particular number. So we'll take 1, we'll circle it and we'll bold it because 1 is a solution. Another solution is 0. So in a similar way, we'll take 0, we'll circle this point in the number line and we'll bold it. Keep on doing like this. See, this dot 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 means we need to keep on going till infinity. So as we cannot go till infinity, what we'll do is we'll bold the arrow. This represents that we need to take numbers continuously on the line as we proceed. For the second part, here the replacement set is the set of real numbers. Therefore, the solution set will be for this will represent it as x such that x belongs to a real number and x is less than 2. Why we are representing like this and not in this tabular format is because if we represent in tabular format, we do not know how many numbers are there in between 0 and 1. Between 0 and 1, like for example, we can say we have 0.5, 0.2, 0.23, 0.224. So like this there are infinitely many numbers. Since we cannot represent them all, that is why we write in this format where x such that x belongs to a real number and x is less than 2. This colon here is pronounced as such that. Or You can also write this as x is less than 2, so 2 is not included. So whenever the digit is not included, we put an open bracket. This circular bracket or the first bracket is basically the open bracket, and this keeps on going till minus infinity towards the negative side. So we can also represent it in this manner. And in the graph, we are again taking 1 centimeter gaps. Zero, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, so x is less than 2, so 2 is not included. In this case, when it is a real number, what we'll do is we'll circle it and will not bold it. We say that this circle is open. We'll take 1, 1 is included, 0, minus 1, minus 2, minus 3, minus 4, and we'll have going this till minus infinity. And since over here x is a real number, so it will have all the numbers in between. To represent all the numbers in between, what we'll do is we will just bold the line that we had. So we'll bold this line a bit more. Okay, so x less than 2, x is going till 2 but not including 2. So it will have 1.9, 1.999 also, but is not including 2. That is why 2 is an open circle, and before that we have bold everything. This is how we represent the solution set of real numbers on the number line. The third question. Solve 5 minus 2x by 3 less than equals to x by 6 minus 5. So the solution 5 minus 2x by 3. Over here if you see, there is no solution or replacement set mentioned in the question. Whenever there is no replacement set mentioned in the question, just remember that it means a real number. You need to find the solution according to the real number. So we'll multiply by 3 on both the sides. So okay, this is 3 less than equals to x minus 6 5s are 30. We are taking the LCM and we are getting 6 over here. So we need to remove 3 as well as we need to remove 6. So what we are doing is we are multiplying by 6 on both the sides. So since 6 is a positive number, so we do not need to worry about changing the sign of inequality. So 3 and 6 cancels off, into 2 is less than equals to x minus 30, 6 and 6 cancels off. Or 5 to 10 minus 2x into 2 is 4x is less than equals to x minus 30. Now we'll add 30 to both the sides. So we have 10 minus 4x plus 30 is less than equals to x minus 30 plus 30. So 10 plus 30 is 40 minus 4x is less than equals to Minus 30 plus 30 cancels off x. Now we'll add 4x to both the sides. So what we get is 4x cancels off, 40 is less than equals to 5x. Or we'll divide by 5 on both the sides. 5 being a positive number, we do not need to change the sign of inequality. 5, 8, 40. 5 and 5 cancels off x. Or see here 8 is less than equals to x, or if you read it like this, x is greater than or equals to 8. So x is the side where x is there, the mouth is open. So x is greater than or equals to 8. So therefore how we represent this is x such that x belongs to a real number and x is greater than equals to 8. Or here for this loose inequality, when equals to is there, when we need to show in terms of interval, your interval becomes 8 is included, so we have a square bracket here, comma, x is greater than or equals to 8. There is no upper bound, this will go till infinity. So 8 till infinity, and infinity we have an open interval. So you can also represent the solution in this manner. So the next question, number 4. This is also an important type of question. Please mark this and go through the solution carefully. Solve x minus 3 into x plus 5 is greater than 0. Also, represent the solution set on the number line. Okay, solution. Case 1, we will divide this in two cases. The reason being, if say x minus 3 is positive and x plus 5 is negative, so positive into negative will become negative. It will not be greater than 0. So if both are positive, the multiplication will be positive, or if both are negative, then the multiplication is again positive, because negative into negative will become positive. So in the first case, we will take x minus 3 greater than 0 and x plus 5 greater than 0. If it were to be less than 0, then one should be positive and the other should be negative. Here it is greater than 0, so both must be positive. Multiplication of two positive numbers give us positive. So or x is greater than 3 and x is greater than minus 5. So and represents intersection. Intersection basically means whatever is common in both of them. So what we get as a solution is that x such that x belongs to real number and x is greater than 3 and x is greater than minus 5. So whenever we have an and over here, we always take what is common in both of them. So this will be equals to x such that x belongs to real number, and if you see x greater than minus 5 and x greater than 3, the portion that is common in between them is what is x greater than 3. Because from minus 5 till 3, this portion is missing in this one. But x greater than 3, this one is present in this as well. So whenever we have and in between two of them like this, we only take that is common in both of them. And basically represents intersection. So for we have the solution for case 1, and for case 2 we'll have x minus 3 less than 0 and x plus 5 less than 0. If both are negative, also negative into negative will become positive. So adding 3 to both the sides, x is less than 3, and adding minus 5 to both the sides, x is less than minus 5. So we get here the solution set is x such that x belongs to real number and x is less than 3 and x is less than minus 5. In this case, when we took the greater sign, the common one in both of them was one which had the bigger number. But when we take the less than sign, the common one in this two will be the one which has the smaller number, because x less than 3 and x less than minus 5, x less than minus 5 is from minus infinity to minus 5, and x less than 3 is from minus infinity to 3. So from minus 5 to 3, this portion is there in this, but minus 5 till 3, this portion is missing in this one. So what we are taking is x such that x belongs to real number and x is less than minus 5, because the common in this and this and represents intersection. So the common elements in this and this will be the ones that is less than minus 5. Okay, to understand this better, you can also see this one. This is just a rough work. Do not copy this one. So see, minus 5 is on the left hand side, 3 is on the right hand side. So x greater than 3 means this portion, and x greater than minus 5 means this portion. So what is common in them is x greater than 3. Over here, x less than 3 and x is less than minus 5. So minus 5, 3. X is less than 3 means this portion, less than 3 left hand side, less than minus 5 is this portion. So what is common is till here. So that is why x is less than minus 5. These are just rough works. Please do not copy them. It is meant for your understanding. Combining both the cases, we get x such that x belongs to real number and x is less than minus 5 or x is greater than 3. We can have this solution or we can have this solution. Or denotes a union, and we can have this also as the solution and we can have this also as the solution. So or denotes this can also be the solution, this can also be the solution. So to represent it graphically, So x is less than minus 5. Minus 5 is not included. Let's just add one more number. Let's say this is minus 6, and see if we add a little more. Okay, so minus 5 will not be included, and x is less than minus 5 means minus 6 is included, and this also we need to bold it off. And we'll bold the line as well. And for this one, x greater than 3, so 3 is not included, 4 will be included here, and we need to bold this line as well, because all the elements in between is also included. Whenever x is a real number, we need to include all the numbers in between, so we need to bold the line. So this is your solution on the number line. The next question, number 5. The diagram given below represents two inequations P and Q on real number lines. P is given by and Q is given. I'll draw the number lines. First part, write down P and Q in set builder form. Part 2, represent each of the following sets on different number line. Number A, P and Q. Number B, P intersection Q. Number C, P minus Q. Number D, Q minus P. Number E, P intersection Q dash. And number F, P dash intersection Q. Okay. P starts with minus 2, does not include minus 2, it goes till 6 and 6 is included. So we have everything in between. We'll just bold the line. And Q starts with 2, includes 2, goes till 8, excludes 8 and everything in between. So we'll bold the line. Now this is our question. So first of all, we need to write P and Q in terms of set builder form. So in solution, part 1, we have P as X such that X belongs to real number because everything in between is included, and if you see X is greater than minus 2 and X is less than or equal to 6 because 6 is included and minus 2 is not included, that's why no equality sign. So this is our X. For Q, we have Q starts with 2, so X such that X belongs to a real number and X is greater than or equal to 2 because 2 is included and it is greater than or equal to 2 and is less than 8. It is not included, it is not bold. So this is our set P and Q. For second part, say A, we have P union Q. P union Q means we'll include all the points that is in P as well as in Q. Union means combining both of them together. So P union Q will become X such that X belongs to a real number. This will start from minus 2 because the smallest in between these two is minus 2 and go till 6 we have, and from 6 also it continue till 8. So X belongs to real number and X is greater than minus 2 and less than 8. Combining both of this, all the values of this and this, what we get is X is greater than minus 2 and X is less than 8. Everything in between is covered over here. For part B, P intersection Q. So P intersection Q will become, intersection basically means and union basically means or. So in the and part, what we'll do is we'll only take that portion which is common in both of them. So minus 2 to 2 is present over here, but it is not absent here. And from 6 to 8 is absent here, but is present here. Since it is absent here, we'll exclude that as well. So P intersection Q will have X such that X belongs to real number, and X common in this will start with 2. X is greater than or equal to 2 and less than or equals to 6. Till 6, from 2 till 6 is common in here or as well as common over here as well. So this represents your set intersection. Number C, P minus Q. So when we subtract two sets, what happens is we are taking the main set as P and we are subtracting all the elements that is present in Q. So we have minus 2 to 6. What we are removing is the set Q. From 2 to 8 we need to remove. So this portion from 2 to 8 is being removed. This is being removed. So we have starting with minus 2 till 2, and since 2 was included over here, we have removed 2 as well. So P minus Q will contain X such that X belongs to real number and X is greater than minus 2 and less than 2 because we have excluded 2 as well. This whole portion has been removed from P. Number D, Q minus P. So Q minus P, the main set here becomes Q and we remove everything that is there in P. So from minus 2 to 6, minus 2 to 6, this portion is being removed. So what is left is from 6 till 8. So X such that X belongs to a real number and x is greater than 6 and less than 8. Since 6 was included here, we'll remove 6 from here as 6 is removed. So 6 is not included in Q minus P. Number E, P intersection Q complement. So what does Q complement means is we'll remove this and we'll take everything else. So when we take P intersection Q complement, P is x such that x belongs to real number and -2 less than x less than equals to 6 intersection Q complement. So Q is this much. So Q complement will become x such that x belongs to real number and so x is greater than 2. So its complement will become x is less than 2 and x is less than 8. So x will be greater than or equal to 8. If 2 is included here, 2 is excluded here. If 8 is excluded here, 8 is included here. So when we take the intersection of both of this, what we will get is x such that x belongs to a real number and so on intersecting these two, so x was less than equals to 6, here x is greater than equals to 8. So there will be nothing in common. And for this 2, what will happen is -2 to 2 is common and below this also nothing is common. So x is less than 2 and greater than -2. This will be the common portion. If you get confused, you can also do this in rough. Do not do this in fair. We have a -2, 1 digit, 2 digit, 6 we have and 8 we have. So first part is from -2 to 6. 6 is included, closed circle, this one. And for this one we have x is less than 2. So this whole portion and x is greater than equals to 8. So this portion. So what is common is only this part from -2 to 2, excluding -2 and excluding 2 as well. So that is why we are getting this portion. This is only your rough work. Do not do this in your fair part. For F, P complement intersection Q. Complement is basically we'll remove everything that is there in P and whatever will be remaining will be our complement. So this is equals to P complement. What will happen is x such that x belongs to real number and x will be less than or equals to 2 or this should not be and this should be or x is greater than 6. Intersection Q. Q is basically x such that x belongs to a real number and x is less than equals to 2 and less than 8. So for what is common in between them, we can use the same method like we used over here. What we will do is we'll write a number line, write all the digits that we are using over here. We are using -2, 2, 6, 8. So the first set is x is less than or equal to -2. So this portion and x greater than 6. So this portion. And for the second one, x is between 2 and 8. So between 2 and 8 and 2 is included. So this portion. So the common is this portion. So the resultant set will become x such that x belongs to real number and x is in between 6 and 8. Between 6 and 8 where both are excluded. So this is our solution set. You try and draw the real number line for all of this. If there is any confusion with the real number line, we'll deal with it. This is what you need to draw on the number lines. this one and the final sets only. You do not need to draw all the sets. Okay. And the last question, I leave some space for you to draw the lines. And the last question, number 6, find all pairs of consecutive odd natural numbers both of which are larger than 10 such that their sum is less than 40. Okay, so we need to find pairs of consecutive odd natural numbers. So let the consecutive odd natural numbers be x and x plus 2. Why we are taking x plus 2 is because say take an odd natural number, say 11. So the consecutive of 11 will become 13 because we are taking odd natural number. So 11 and then 11 plus 2 we have. That is why we are taking x and x plus 2. So their sum is less than 40. So x plus 2 should be less than 40, which gives us x plus x is 2x plus 2 is less than 40, or we subtract 2 from both the sides, 40 minus 2, or 2x is less than 38, or dividing 2 from both the sides is less than 38 by 2, or x is less than 19. So x less than 19, so we get, so 1, okay, let's take pairs of consecutive odd natural numbers both larger than 10 such that their sum is less than 40 are. So the first pair, since we need to take numbers larger than 10, so x is less than 19 and x is larger than 10. So first odd natural number is 11. So 11, so x is 11, 11 and 11 plus 2, 13. This is one pair. Another pair is 13 and 13 plus 2, 15. Another 15, 15 plus 2, 17. Another 17, 17 plus 2, 19. This is x, this is our x plus 2, and x should be less than 19. So as x is less than 19, we cannot take 19 over here. But we can take 19 in the second one because this is not x, this is x plus 2. So with this, we come to the end of this lecture. If you have any confusion, we'll clear them out in our Zoom discussion classes. Thank you.